we're going to talk a little bit about real zeros of polynomial functions. And the first thing I'd like to do is review polynomial long division. So this is the division algorithm. I just want to make sure you know all of the terms. So if you divide two numbers, or two functions, I should say, the one on the top of the fraction, or the one that you're dividing the other one by, is what we call the dividend. The one on the bottom of the fraction, or the one that you are actually dividing by, is called the divisor. Actually, if you were to write this out in this way, the dividend would be in here. The divisor would be on the outside. So just keep that in mind. Your answer, remember, is called the quotient. So that's right here. And then this thing, whatever's left over, is called our remainder. So hopefully you remember this you remember what a dividend, divisor, quotient, and remainder are. We actually will write our final answer as the quotient plus the remainder over our divisor. So I'm hoping that this is a review from elementary school. However, I do like to go over this just because the steps for polynomial long division are exactly the same as the steps that you learned in whatever 5th grade or whatever year you did it. So we always start by looking at our first digit, which is 5. We look to see if 32 goes into 5. We know it doesn't, so then we're going to move on. Now we're going to look at 54. We know that 32 goes into 54 once. We then multiply the number that we got by our divisor. Then we change to subtraction. And when we do that is the exact same step that we're going to do every time we use polynomial long division. So we subtract that, we got 22. We bring down our 8. Again, that's going to be a step that comes up again. Now you need to figure out how many times 32 goes into 228. It does end up being 7. I'm actually going to work through the entire thing on my own. If you want to, you can just fast forward until the very end. You probably know how to do this, but I just wanted to draw a parallel to what we're going to be doing in just a second. So our final answer is 171 with a remainder of 11. Remember, we write that as 171 plus 11 over 32. If you use your calculator to divide this out, you end up getting 171.344. That 0.34 that you get is actually equivalent to 11 over 32. So now we're going to do this with polynomials. So we're going to divide 4x cubed minus 4x squared minus 5 divided by x minus 3. You are welcome to try this on your own and then just fast forward to the answer. So we're going to write this. Make sure that you write x minus 3 as your divisor. It's really important to notice that we are missing a term. You have to have all terms starting at x to the third all the way down to the constant. We have to have them all represented. So we're missing an x term. The way that we're going to compensate for that is writing a plus 0x. We need to have that placeholder in there. So don't forget to do that. It's an important step. If you miss that, you'll actually get the entire problem wrong. Okay, so then we're going to start off. We do 4x cubed divided by x. That gives us 4x squared. I like to keep it organized, so I put my squared term above the squared term in the dividend. From there, I am going to multiply my 4x squared, which is this right here, by my x minus 3. If you want, you can do that on the side. I think most of you can probably do this in your head. So when I do that, I end up getting 4x cubed minus 12x squared. Next, we are going to change to subtraction. This is the same step as you did in the previous like elementary school long division thing. So I'm going to do minus, this entire thing becomes negative. So because the entire thing becomes negative, the 4x cubed is negative, and then the 12x squared becomes positive. So these things give you 0, and I end up getting 8x squared. I do want to comment, if you get something other than 0 when you do this, you made a mistake. So if things do not cancel out, you made a mistake, and you're going to have to go back and find that mistake. Usually the mistake is not subtracting. Sometimes there's just other things wrong, so please make sure that you check that. Next thing I'm going to do, I tend to bring down my next term at this step. You actually can get by without doing that, but I think that's the easiest way to do this. And you're going to repeat the process. So now I'm going to take 8x squared, I only look at my first term, divided by x. 8x squared divided by x is going to be 8x. Then I'm going to multiply once again. And I'm not going to show it on the side, but I'm doing 8x times x minus 3. That gives me 8x squared minus 24x. Again, I am going to change this to subtraction and then change the minus 24x to addition. I end up getting 24x. Now I bring down my final term, which is minus 5. Again, I am going to do 24x divided by x. That gives me a plus 24. And then I multiply through again. So I get 24x. Negative 3 times 24 is minus 72. I changed this entire thing to change signs on both of these. So I change it to subtraction. These cancel out. I am going to be left with 67 as my remainder. So please keep in mind that 67 is not my answer. My answer, it includes 67, but I have to write it in the form I had on the previous page. So my answer is going to be this, which is my quotient, plus my remainder, which is right here. And my remainder is going to be divided by the divisor. So just make sure that you write it in the proper format in the end. So I'll write it out like this. If you just give me your remainder as the answer, that's actually not right. And you probably will lose points even if you do everything else right. So be careful on that. So before we go on, I want to mention one thing. And that is, if you have a divisor like this, x minus 3, if you take the opposite sign of that 3, which is just positive 3, and you find f of 3, f is this original function, believe it or not, your answer there is going to be your remainder. So I'll show you what I mean. If we do this, our answer will end up being our remainder. This is what we call the remainder theorem. And it's you're probably not going to use it that often in this form, but it leads to something else that's really important called the factor theorem, which we're going to talk about right now. We have a theorem called the factor theorem that's really helpful. So basically what it says is that if you have a polynomial and x minus c is one of its factors, then the c value is going to be equal to 0. And I want to point out one thing that you might want to know if you're going to take college level math classes, and that's this use of if and only if. Sometimes, by the way, if you get a really lazy teacher, and I'll admit I'm guilty of doing this sometimes, if they see if and only if, they write if with an extra f. I know that's weird. So that means that basically what this means is that if x minus c is a factor, then f of c equals 0. That's the first part of it. The second part is if f of c equals 0, then x minus c is a factor. So you're going to see things written with if and only if. And actually another way that you'll see that written is you'll see it written as an arrow that goes in two directions. So there's a lot of ways to write that. If you are doing a major in college that does not involve a lot of math classes, it's likely that you probably won't see this very often, but I just kind of want you to keep this at the back of your mind in case that type of thing comes up later on. We're going to do an example, and we have a function. We want to know if x minus 1 and x plus 2 are factors of that function. So basically, there's two ways to do this. One of them is really easy, and one of them is a little bit less easy. It's not that it's hard, it's just a little bit longer. You're most likely going to be doing it only one way, but I just want you to know both ways. So the first way to do it is if you do f of x divided by x minus 1, it will have a remainder of 0 if x minus 1 is a factor. So we're going to see if that happens. So I'm going to go ahead and divide this, but this time I'm going to divide it using synthetic division. If you have done them both and you prefer the long way, you can. We're going to review it very, very fast. Basically what you're going to do, synthetic only works, by the way, if you have a factor in this form where you have x minus something or x plus something, or if you have a divisor in that form, you're going to take the opposite sign of that number there, the 1, so it's going to become just positive 1. And we're going to use the coefficients of our f of x. So we use our coefficients and our constant. So I'm going to use 2, -1, 2, -3. So I start by bringing down my first term. Then I'm going to do 1 times 2, 1 here, the 2 here. I multiply those together and I get 2. The next thing I'm going to do is add the two terms that I have right here. I add these, so these are going to be added. I get 1. And then I continue doing the same thing. I do 1 times 1, I get 1 again. Then I add my terms again, I get 3. Then I do 1 times 3, I get 3 again. And actually this right here at the very end is going to be my remainder. So that tells me that x minus 1 is a factor of f of x because my remainder was 0. So the answer for that one is yes. So I'm just gonna write that yes. Now, you probably don't want to be dividing every time unless you really love synthetic division or if you like long division. So rather than doing it that way, I'm going to just draw a little box over here to figure out if x plus 2 is a factor. We're going to do it using the factor theorem. And we're going to see if we were to find out f of -2, remember I take the opposite sign of that plus 2. We want to know if that is going to be equal to 0. If it is, then we know x plus 2 is a factor. If it's not, then it's not a factor. So go ahead and evaluate f of -2 on your own. Pause the video. So when I work that out, I get -27, which is completely not equal to 0. It's not even close. So for that one, I can say that no, it is not a factor. The last thing I just want to mention is the number of real zeros. So we have a rule in math that a polynomial cannot have more real zeros than its degree. So for example, if you look at the previous example, we had a degree 3 polynomial. It was this right here. Even without without dividing it out, without finding all of our zeros, this has at most 3 real zeros. Now it might have less, and you'll notice I put the word real in there. That's an R, by the way. So we might also have complex zeros. We'll talk about that in another time, actually in the next time. But just keep in mind it has at most 3 real zeros because our degree of that function is 3 because of that exponent of 3 there.